Measures of dispersion. Measures of dispersion indicates the scattering data. It explains the disparity of data from one another, delivering a precise view of their distribution. It displays and gives us an idea about the variation and the central view of the individual item. Measures of dispersion include the range, interquartile range, standard deviation, and variance. There are two types of measures of dispersion: the absolute measures of dispersion and the relative measures of dispersion. Absolute measures of dispersion. Absolute measures of dispersion contains the same unit as the original set. It expresses the variation in terms of the average of deviations of observations. It includes range, standard deviation, and the quartile deviation. Range. It is simply the difference between the maximum value and the minimum value given in the dataset. So the formula is range equals highest value minus lowest value. Example given are 12, 13, 15, 12, and 18. So the highest value is 18. And the lowest value is 12. So range equals 18 minus 12. The range is 6. Variance. Deduct the mean from each data in the set. Square each of them and add each square and finally divide them by the total number of values in the dataset to get the variance. So here is the formula. This population standard deviation. Where individual value, x is the individual value, all the mean or the mean, population mean, n is the population size. Next is the standard deviation. The square root of the variance. It is popular and it is the most reliable measure of variability, expressed in the same units as the raw data, unlike the variance, which is expressed in square units. Here is the formula. We don't have it. Next is the sample variation. Sample variation is a measure of the degree to which the numbers in a list are spread out. If the numbers in a list are all close to the expected values, the variance will be small. If they are far away, the variance will be large. The formula is S squared equals the summation and the mean minus mean, while the sample standard deviation is this: S equals square root of S squared equals squared summation of, and then example. A sample of 6 vendors along Rojas Night Market were surveyed and obtained their average daily income as follows: 500 pesos, 650 pesos, 350 pesos, 290 pesos, 440 pesos, and 490 pesos. Compute the variance and the standard deviation of their income. Number 1. First step is to arrange the data in column. So this is the table, and we put here the given, and then sum them up. So the answer is 8,000, and then done. Next is to get this 8,000 divided by 10 minus 760 is equals to 40. Next. is same process, 8,000 divided by 10 minus 840. Negative 40. Negative 40. Next, 8,000 divided by 10 minus 690 is equals to 110. Next, 8,000 divided by 10 minus 920 is equals to negative 120. Next, same process, so the answers are negative 170. Next, 8,000 divided by 10 minus 850 is equals to negative 50. And the last one, 8,000 divided by 10 minus 770 is equals to 30. Next, we're done here. So next, to get the answer here, we have to follow this. So our process is to multiply it by itself. So 40 times 40 is equals to 1,600. Next, negative 40 times negative 40 times negative 40 is 1,600. Next is 110 times 110 is equals to 12,100. Still the same process. $48,400. 8,100. 4,900. 8,000 divided by 10 so we're done of computing them, so we have to add them all. So the equals is, the total is 123,400. We're done in making the table. So next is to compute the mean. Same process. We have to get the mean 8,000. 8,000 divided by how many are they given? So 10. 10 are the total of the given. So the equals is 800. So that is the mean. Then here mean. So we're done of computing the mean. Next is to compute the variance. So the variance is this. This is where we have given so 123,400 divided by 10 minus 1 so 123,400 so it's 9 already because we subtracted that from 1. The variance is 1,000. We have to solve it first. 1,400 divided by 9 is equals to 13,711.11. So that is the variance. We're done with computing the variance, so we'll proceed of computing the standard deviation. Again, same process. The standard deviation, this is the variance. So the variance is 13,000. Copy. Next. But we have to square it, so we'll put the square root. Here. So 13,000. So the square root of 13,711.11 is 13,711.11 is 117.9. Equals 117.09. So that is the standard deviation. And done. And we're done of computing the